All right, we're going to do something a little different this weekend with our weekend podcast. Hey, I'm Kevin, the PT Guru. I do a podcast. Today, we're going to video it and throw it up on YouTube, try to get some awareness going about the podcast that I do. This is actually my 8th weekend podcast, and I actually do a daily podcast, Monday through Friday, every week for about 2 months ago. We talk about calibration and measurement and all kinds of cool stuff like that. So I'm going to bump it right off by telling you about what we talked about over the course of this past week. So if you're new and checking this out on YouTube, you can go find those videos if you want, or podcasts, not videos. This is a video. And so Monday we talked about drift in calibration, how we can use drift calculations to figure out how a calibrated item or standard is trending over time. This can allow us to save some money by extending calibration cycles. It can also, though, help us save money by shortening calibration cycles when we have a problem where we might think we could be possibly having to recall product. Good to catch that one in advance, isn't it? Then on Tuesday, kind of furthered the saving money on calibrations idea and to talk about choosing what we maybe should and shouldn't be calibrating based on how it's used, what it is, what it's for. A lot of places these days are just kind of throwing out complete calibration programs saying don't do anything. We want to save the money. We don't see value in it. Well, it might make a lot more sense to actually just kind of go through your calibration program with a fine-tooth comb and say, hey, these are things we really need, and hey, wait, yeah, we can definitely live without some of these things. So then on Wednesday, we talk about some kind of equipment, and this Wednesday we did transducers. So if you ever kind of wondered how a measurement makes its way into a computer system, a recording system on your iPhone, this is what transducers do. They convert signals. So kind of some fun stuff there. That led me to Thursday's talk about the signal chain. So you got a transducer and you've got some other things happening in between where that happens, and the end of the line is, how are you figuring out that measurement itself is still true all the way through the chain. And then on Friday, we talked about method validation. So if you do have stuff calibrated, how do they choose methods, procedures? How do they come up with ways to do all this stuff? And that's what method validation is all about. So kind of a fun one there. So that's kind of our weekend review with the podcast that we did this week. We're going to get right down to some content. And this is on the weekend podcast, I kind of like to talk about like higher level topics. And here we're talking about reverse engineering success. In life, measurement, calibration, metrology, any of these things, this one thing really holds true. If you start out knowing where you want to get to, you're going to have a much better chance of getting there. End of story. No, not too much thought has to go into that statement. So when I think about calibration, and I'll say, reverse engineer it. Consider your end game first. What do you want to get out of this calibration? Is the calibration actually going to suit how you're using a particular item? And I'll be honest with you. Most people think that what they want out of calibration is a sticker and a certificate that says it's met some form of compliance. It passed calibration. And that is the exact dead wrong way to look at calibration. Just wrong. Now, I'm sure if you're a calibration technician, any kind of technician, a compliance person, a quality professional, that is so counterintuitive right now that you're probably throwing something at your iPhone screen or your computer as you listen to me and saying, no, you're just wrong. You're assuming that you have and are using the right instrument to do a particular job. You're assuming that the calibration lab has done what you need for them to do, even though you haven't told them what you need. You assume that it's passes, then everything's been done perfect, everything is right, and your world is wonderful. Well, have you considered how you're using what you're using? Have you considered what it is that you're using. Have you considered what the actual end result of the measurement is, or the end result of the measurement after the measurement, after the measurement, after the measurement is that this thing is being used for? So when we really start with the ends in mind, it is going to make this a lot better. I don't know how many times I've seen an instrument being used incorrectly. I don't know how many times I've seen the instrument just is not the right tool for a particular job, and all the calibration stickers and certificates and met specs, yes, on the certificates is not going to fix a measurement made with the wrong instrument. It's not going to happen. It's not going to make it better. If you're not using the right thing, it's still not going to be good. I think of those huge 10-foot long carbon fiber calipers that people use. And I've talked to the folks that use them before, and they're like, yeah, we use it for this measurement or that. And I'm like, you do know that the accuracy on this thing is horrible when you get past that first 6 to 12 inches. And we'll look up the specs together on it, and they'll just be blown away by how horrible that measurement is, because they're used to using their other calipers that are only 6 and 12 inches long that are significantly more accurate. And then if I start to tell them about the temperature differentiation issues with the carbon fiber versus the other materials that they're actually measuring, and versus the temperature differential, and it just blows up even bigger at that point. It's really crazy. But I was trying to rack my brain to come up with a good example of kind of using the wrong instrument, and I came up with one that happened to me years ago, and it was a customer that I had. He had several gravity ovens. Now, a gravity oven is just like the oven in your house. It doesn't have convection. So what happens is it forms its own natural convection by the heating and natural cooling of the air, and you end up with this sort of rolling pattern of heating, cooling air in there. They're great for what they're designed to do. They're not super accurate ovens. Neither is the oven in your house. Map one sometime. It's really hilarious. But that being said, they have controllers. They read out to a degree, 1 degree C, which is great for this kind of sort of oven because they're not super accurate anyway. And this one even had solid shelves, which makes it even kind of worse. The solid shelves don't let the air circulate the same way as maybe shelves that have some holes in them or are made of some kind of wire mesh that you'll see frequently in different types of ovens. So the customer wants this thing held, though, to a specification of plus or minus half a degree Celsius. Now, I can dial in an oven with the best of them, and I did this about 10 years ago, and I just didn't know as much as I do now, and I sure as heck wasn't as good as dealing with customers, people in general, as I am now. So I did what he kind of asked me to do, and at that point what I did was I lined up my RTD probe with the temperature sensor for the actual oven, and just tweaked it in over the course of several hours. He actually had about a half dozen of these ovens and set up in several different labs, and got it in within that half degree mark and called it a day. So was pretty sure the customer was happy. I really didn't know how to have the conversation that I should have had at that point, and so I didn't. And of course, a week later, in comes the call. The ovens weren't meeting his specification. So me and another coworker, just to bring a second person to have that second set of eyes to, try to reassure this customer of what I was doing, head off to go see this customer again. And he, is not particularly happy. He says that the ovens are off by a couple of degrees, that I must have did it all wrong. And okay, so at this point, he kind of forced me into having the conversation. So I started out with the obvious, what are you using to measure your oven? So here's another problem that I came across here. He was using a thermocouple with a thermocouple thermometer. Now, the thermocouple itself, I'm 99% sure was not calibrated. However, the thermocouple thermometer was, so half right. But even if the thermocouple was calibrated, a standard thermocouple like this has a accuracy of about plus or minus 2 degrees C, give or take, based on type, other things that go into the requirements there. But even if it's a really good quality thermocouple, the special limits thermocouple, that's going to drop it down to like 1 degree C. But still, we're talking about he wants this half degree on a 1 degree display. That's going to be a problem. That's not the right tool to make that measurement. So next, I use my RTD, kind of try to have that conversation with him. He was kind of irate though, so he wasn't buying it. Been there before. And what I was able to then show him was with my RTD, I took several measurements across different shelves in the oven and was able to show him that it's a 2 degree difference from different positions in the oven. And then I placed my RTD right next to the actual temperature probe for the oven. And guess what? It was right there where I dialed it in within plus or minus like 0.2, 0.3 degrees. It was really quite impressive in this particular case. So what we have here is that a customer was trying to use these ovens for the wrong tool for the job that he was intending to do. There's no way of getting around that. Now, there are other things he could have done to make it better, but just the design and overall functionality of these ovens, there's a reason they only read to 1 degree. The manufacturer could have put in a better controller. The manufacturer could have put in controllers that read an extra decimal place. They didn't. Why? Because they know that it's not that accurate. They know that once you map it out, it's not going to meet that kind of specification. So now here's the best part. After listening to that story, how many of you would have assumed that the oven was accurate or as close to accurate as this customer did, just based upon the fact that it had a calibration sticker on it? I bet there's a lot of you that would have. The thing with calibration is that you guys, a lot of folks, are going to equate calibration with accuracy. These are not the same thing. And you got to drop that premise. You need to look at what the accuracy tolerance, what the specification for a particular instrument is, and realize that the calibration is simply a comparison of measurements. Now, if that measurement happens to be within that tolerance band, typically we're going to say, yes, it passes this calibration. However, that tolerance band might be much wider than what you think it is, hence the 10-foot long carbon fiber caliper. So this experience, I remember it really well because it really changed the way I communicated with customers. I started to ask more questions up front. Tried to get people to think, try to get that brain going, to really challenge them to dig into how they're using their equipment and not just going, hey, it's calibrated, everything's fine. And now, sure, I get brushed off most of the time when I try to have this conversation. I get the attitude that says, just put a sticker on the damn thing and let me be on my way. But I got better things to do with attitude, so I ain't worried about it. But for the handful of customers that do listen and are willing to listen, I've found that they really can elevate themselves in their position, in their understanding of this greater measurement concept an idea. And the really cool thing is that the even smaller handful beyond that come back to me 2 and 3 years later and say, hey, you remember when you told me about, I really dug into that and I found out. And the conversations are great to have, and it'll be 6 months, it'll be a year, it'll be all that time later. And they'll remember me trying to get them to think about that thing. So I hope I can challenge you to take it further, to ask these questions, to swim upstream, look at the goal you're trying to get to, envision yourself there, then turn around, look back, and see if that instrument, that gauge, that tool is really what you need to get there. And I also challenge you to do that for the rest of your life. Figure out where you want to get, and then picture yourself there, turn around, look back, and it's going to be really easy to find that path there. So that's what I mean when I say reverse engineer your success. That's what I mean when I say start with the ends in mind. Figure out where you want to be, and then it's going to be really easy to get there. So I thank you. I'm Kevin. Hit me up on the website, www.ptguruconsulting.com. There you can link up to the podcast. You can check out all my social medias down at the bottom. And you can also leave me a message. Tell me how I'm doing. Maybe make a suggestion. Ask questions. I love answering people's questions. More questions you ask, the more I answer. And I love doing that part. So I hope you have a great weekend, and I'm going to talk to you on the audio side on Monday. Thank you so much. Peace out.